Hello, everyone, and welcome to Methodology for a Floating Offshore Wind Turbine Major Component Replacement webinar. So we will present today part of floating offshore wind operation and maintenance, so-called Floaton project, which is a project in partnership with EDF, Ifremer, IMT Atlantique, Inosi, GIFMAR, SBM Offshore, Shell, Skyborn, and Sofrecid, and with the financial support of Région Bretagne. So I'm Laure Cossalter from France Énergie Marine. I will be your host today, along with Tanguy Kokio from France Énergie Marine 2, Benoît Auger from Ifremer, Melissa Mack from EDF Energy, and Pierre-Alain Frémont from SBM Offshore. So if you have any question during the presentation, please ask them in the Q&A button just above the screen, and we will address them during the Q&A session after the presentation. Okay. So let me start with a few words of introduction and context. So today, in the offshore wind sector, the heavy maintenance at sea, such as major component replacement, is still a challenge for research and development because major component replacement contributes the most to OEM costs by material cost, as you can see on the right graph, and repair time, excluding mean time to access, as you can see on the left graph, despite low failure rates. So both of the graphs are extracted from Carroll et al. Wind Energy 2029. And especially in the floating offshore wind sector, accessibility and operability of maintenance method increase in complexity. First of all, because the farms are installed further than the jackup vessel capabilities, but also because relative motion between floaters results in high demand on vessel dynamic positioning system and induce restrictive mid-oceanic windows. So in this context, the sector expressed a need to have reliable and proven solution for MCR operation of floating offshore wind turbine that are cost competitive with tow-to-port alternatives. So as you can see on this floating wind GIP phase 3 summary report graph, so they are in the HLM technology, so among which we have turbine mounted cranes and vessel mounted cranes technology. So there are some technology that are cost competitive to tow-to-port technology, but as we can also see is that they are more sensitive to sea state conditions. So in this context, the Floaton project objective that was carried between 2029 and 2024 is the following. So we challenge floating offshore wind turbine LCOE reduction by improving MCR operation accessibility in different sea state conditions by the development and the assessment of methodology and simulation tools for MCR solution operability evaluation. So you will see in this presentation that through a numerical model that was validated by basin tests, and in which we input operating limits and environmental condition, we can outcome with so time domain computation. We can reach allowable sea states, % of operability, and the favor period of year for MCR operations. So in the following study, we decided to study one MCR solution, which is self-erecting turbine mounted crane. So this solution is advocating improved EHS because there are no relative movements between the floating bodies. It also advocates higher availability, so lower downtime, and it advocates resistance to harsh environment. So in our case study, case study, so we describe our MCR solution, which is inspired by the real MCR solution, but it's not the exact real one, because our objective is to crash test the methodology and is not to assess the full system operability. So in the rest of the case study specification, so for the basin tests, we are studying also a semi-submersible floater, which is the Voltron USS, equipped with a 15 megawatt turbine designed by IEA, and a rescaled monohull vessel, both scaled at 150. And for the numerical study, above the two other bodies described, we are also studying the TLP Float for Wind floater equipped with the 15 megawatt turbine, and both floater equipped with the MCR self-erecting system. And for both cases, we are studying specific lift cases. So you will now listen to the second part of this presentation. So the basin test for numerical model validation. So first of all, Benoît Auger from Ifremer will specify the wave tank tests. Then Tanguy Kokyo from France Énergie Marine will describe the validation of the numerical model. Afterwards, we will have the description of two case studies to study the operability of MCR steps. So first of all, Tanguy Kokyo will describe the methodology developed and the case study specification. Melissa Mack from EDF will describe the case of the transfer of a heavy package from vessel to floating offshore wind turbine. And Pierre-Alain Frémont will describe the hub replacement at the tower top. Then we'll have a Q&A session, and I will conclude and wrap up this meeting.